Welcome to this tutorial on using lookup transforms in integration services. Here's what we'll learn on the tutorial. We'll begin by having a look at our example package, which is to take a set of X Factor finalists and look up the details of each of their mentors in a separate table. We'll have a look at what the package should do, and then have a look at the package itself in SSIS. What we'll then go on to do is look at creating lookup transforms themselves, and then we'll look at how to deal with the output from them. So firstly, how to cope with the output where there's non-matching rows, where we didn't find a corresponding mentor, and then how to cope with the fact when we have found a corresponding mentor. We'll then go on to finish the package using a union query, and finally we'll go on to look at ways to speed up processing the package, either by using full or partial caching with an explanation of what that means, or by using cache transforms. So let's get started. Welcome to this tutorial on using lookup transformations in SQL Server integration services. We've got quite a lot to cover, and it's important, I think, that I explain clearly the example we're going to try to solve at the beginning so you can see where we're going. I've got here the familiar Excel workbook of UK X Factor contestants, and what we're going to do is import these into a SQL Server table. Now, the two contestants I want you to particularly concentrate on are One Direction, a little-known boy band, and New Vibe. If you look at the mentor assigned to each of those, Simon Cowell is assigned to One Direction, and Talisa Kontostavlos is assigned to New Vibe. Now, when we come to import these into our SQL Server table, what we're going to do is look up the mentor's name in a separate SQL Server table of mentors, and here it is. So we've got the mentor ID and the mentor name. When we look up Simon Cowell, there will be no problem. SQL Server will detect the fact that the mentor ID is 8 and store that as the mentor ID against the corresponding finalist. But the problem will come with Talisa Kontostavlos, whatever her name is, because it will then look up her mentor name in the list and fail to find it. And what we're going to do then is store the not known mentor ID 9 against her name. If we look at the finalist table which will be imported, One Direction will come in with the mentor ID 8 corresponding to Simon Cowell, and we'll set some notes to say it's imported OK. Whereas New Vibe will have a mentor ID assigned to it of 9, meaning not known, and notes will say that Talisa wasn't found. This is a very standard thing to do when importing data in integration services. You have a set of data. Let me just go back to my Excel workbook. You have a set of data with a lookup field which is more or less populated, but inevitably there'll be new values in that list. And what a lookup transformation allows you to do is to detect where there's a new value and store a sensible corresponding number next to it. So let's have a look at the integration services package which will achieve what we want to achieve. On the control flow side, it's extremely simple. There's only two tasks. The first one is an execute SQL task, and if we have a look at the SQL assigned to it, all it will do is truncate the table of TBL finalist. So basically it will remove all the old records ready for the new ones to come in. The only other task is a data flow task, and if we have a look at that in more detail, this is of course where all the complexity lies. We'll begin with taking Excel source of the finalists using an Excel connection manager, and we'll feed that into a lookup transform. And what this will do is spit two streams of data out. If it can't find the corresponding mentor name in the SQL Server table, the rows will flow down the lookup no match output and go to this transform, whereas if it can find a mentor, it will go down the lookup match output and come into this transform. What will happen then, it depends on which path it went down. If it was unable to find a match for the mentor name, what it will do is create a new mentor ID field and assign the value 9 to it, meaning this mentor wasn't known. And it will also set the notes to record the fact there was a problem. On the other hand, if it could find the mentor name, what it will do is just use the mentor ID it's looked up from the other mentors table, and it will record the notes to say that it imported OK. What we'll then do is use a union query to recombine those two sets of data into a single data set and export that into the SQL Server table of finalists. So we'll begin by having a look at the lookup transform, and to do that we need to go on to the next part of this tutorial. Before we create the lookup transformation, let's have a look at what element of the package I put in place already. On the control flow side, we've got an initial execute SQL task, which will run against the connection I've already created to the X-Factor database and truncate the table of finalists. So basically, we'll remove all the old finalists ready to import the new set. And I've also got a data flow task which will import the new set of data looking at the mentor's details, and of course it's that which we need to look into. So if I go into that, I've already created an Excel source which will take the worksheets of finalists, and what I'm now going to do is create a lookup transform to split them into those who have mentors and those who don't. I've already cunningly got the name for this task in the clipboard, so I'll paste that in. And then very carefully, I will resize this, because resizing tasks with long names in SQL Server Integration Services isn't an easy thing to do. What I'm now going to do is feed the output from the first worksheet into this lookup transform in familiar fashion, grit my teeth as it resizes it, and get it back to how I want it to look. And then what I'm going to do is configure this lookup transform so it spits out two types of data, those finalists who have got mentors in the mentors table and those who don't. To do this, I need to double click in it as always. I'm going to explain cache mode later towards the end of this tutorial, so for the moment I'll just leave them as the default settings. And I'll go straight on to the connection. The table or view is not the one of finalists, which is where the data is coming from, but the table in which I'm looking up the mentor's details. So I choose the mentors table to be the one containing the lookup information. If you use Excel regularly, you can think of this as your lookup table. Now I'm going to look at the columns, and what I'm going to do is say that the mentor name in the finalist table should match up to the mentor name in the lookup table. And I can do that by dragging one column onto the other. What I now need to do is say which columns I'm going to export from this lookup transform. And the only thing I want to actually keep is the mentor ID. So I'm going to add that as a new column to the output. So now I've got the situation from the lookup transform, it will send out all the existing columns from the finalist table as output, plus one new one called mentor ID, which I want to add as a new column, which is actually the only choice. And I'm going to give that new column the name of mentor ID, the same as it was called in the lookup table. So I can then choose OK. Now unfortunately there's one thing I've forgotten to do, which is to specify what will happen to the information coming out of this lookup transform. So I'm going to go back into it now, and where it says specify how to handle rows with no matching entries, I'm going to choose to redirect these rows to a no match output. Now to see what this means, I'll just choose OK to confirm that. I'm going to add in two derived column transforms, and I'll configure these later in the next part of this tutorial. So I'll put one there, and I'll put one there. When I drag the output from the lookup transform into one of these derived column transformations, it will ask me which output I mean. Do I mean the output where I successfully found a matching mentor, or do I mean, as in this case, the ones where I didn't successfully find a matching mentor? So if I choose OK to that, I can then do the same thing for the other stream of output, and it will automatically assume that I mean the finalists where I've successfully found a matching mentor. So that's what a lookup transform does. It splits the data into two parts, those where it can find a match in the corresponding lookup table, sorry, that one, and those where it couldn't find a match. And in the next part of this tutorial, we'll have a look at the two derived column transformations to see how we can manipulate the data which comes out of the lookup transform. In the previous part of this tutorial, we created a lookup transform to split the table of finalists from Excel into two parts, those where no corresponding mentor could be found, and those where corresponding mentor could be found. What I'm now going to do in this part of the tutorial is configure the derived column transform to create two new columns for each finalist where there wasn't a corresponding mentor. And I think it's worth at this point going back to SQL Server to see what those two new columns will contain. The mentor ID will contain the number 9 because that's the value of the not known mentor. And the notes will say some notes on why the mentor's name couldn't be found. We'll go back to integration services, and I dislike having to hard code any value into a package I create. So what I'm going to do is create a variable to hold the number of the not known mentor. And having little or no imagination, I'll call it not known mentor ID. And I'll give it a value of 9. And the advantage of this approach is that in future, if for some reason the value of that record number changes, what I'll be able to do is just go in and change the value of my variable and everything will still work okay. So what I can now do is probably rename my derived column transform using text already in my clipboard and then resize it. I think I'm beginning to learn the message that long names are bad. And what I can then do is configure it to say how it's going to work. Now I'm going to create 2 new columns as explained. The first one I will call mentor ID. And I want it to be a new column in the table. I don't want it to replace any existing one. I want it to add to the output from the finalist spreadsheet already there. And the expression for this should just be the value of the variable called not known mentor ID. And so I can simply drag that down from the variables into that space. So far so good. The second column I want to create is the notes table. And again notes column. Again I want this to be a new column. And for this one, what I can do is take the column called mentor, which will contain the name of the mentor, drag that into my expression, and then concatenate onto the end of that the words not known. And in theory, that should all work perfectly. However, it will actually yield to a problem. If you look at the length assigned to that by integration services, it's 265 characters. SSIS gets that by taking the standard length of an Excel text column, which is 255, and adding on 10 characters for the words not known. All that would be fine were it not for the fact that in SQL Server, my notes column is 255 characters, and you can't fit 265 characters into 255. What I need to do then is shorten this, and I can do that by converting the type of it using a typecast function. And I'm actually going to use dt_WSTR, which will convert it to a Unicode character string, but with less characters in. So I'm going to change this to 255 characters. And what that should do is truncate it. But it still says 265. And the reason for that is I need to include this expression in brackets so that it's truncating the whole expression to 255 characters and not just the mentor's name. And now it will reduce it back down to 255 characters. If I then choose OK to confirm that, I'm hoping I've successfully configured it so that this derived column transform will take in all the columns from the existing finalist spreadsheet and add 2 more of its own, so that when I come to export the data to SQL Server, I can set the standard 6 columns and there'll be 2 more available to me as well. What I now need to do is do the same thing for those finalists where we did successfully find a mentor in the mentors lookup, and to do that I need another derived column transform. It's time now to turn our attention to the second derived column transform, the one which will take those finalists where we've successfully looked up the mentor ID and add a new column saying that this was imported OK. The first thing I'll do is just rename this second derived column using a name I've got in my clipboard, and with a bit of luck I'll successfully resize it. And what I'll now be able to do is reconfigure this to have a look at the columns it's exporting. It's already got the mentor ID column because we've already successfully looked up the finalist in the mentors table. So all we need to do is add a second column giving some notes. And I'm using the same name as I did in the previous derived column transform just to make life easier. I'm going to put the expression for that as a bit of text saying that I was able to import it OK. And if I then choose OK, with a bit of luck, both the 2 derived column transforms are now exporting the original columns in the finalist table plus 2 more, the mentor ID and the notes. In the case of this derived column transform, the mentor ID is being set to 9. In the case of this derived column transform, the mentor ID is the one which we've looked up in the mentors table. The last thing we need to do to get our package working is to recombine the two tables together using a union-all query, or union-all transform I should call it. And so to do that, I'll choose a union-all transform, add it into my package, and then direct the output from my two derived column transforms into it. And I'll also rename it so it says it will combine the tables back together, which seems a reasonable name. What I'm now going to do is configure this to check that columns are being mapped correctly. And you can see for my two new columns, Mentor ID and Notes, they're being exported into an output column with exactly the same name. Had I not given such consistent names to my columns, I would have had to create a new column and map columns from the original two tables onto it. But because I chose consistent names, I don't have to do that. So I can choose OK to confirm that. And what I now need to do is to direct the output from this union query into my SQL Server table. And to do that, I can put in a destination assistant. I can choose my SQL Server connection I've already got created. I can direct the output from the union-all query into it. And I can configure my destination to say that the information is going into the finalist table. And then finally, I need to go into my mappings. And what I need to do is check that the right columns from the source are going to the right columns in the destination. And as that happens, the ID is going to a column called Excel Finalist ID. The name is going to a column called Finalist Name. And the finished column is going to be the position in which the finalist finished. And we're going to ignore the other columns. If I then choose OK to confirm that, I think I've now got a working package. So let's give it a whirl. If I run my package by clicking on the play tool, hopefully it will import the data, lots of green ticks, which is a good sign. And you can see the 5 rows have gone through the no match output pipe, and 103 rows have gone through the match output pipe. Those are then recombined back here to send 108 rows into the final table. So if I have a look at that final table in SQL Server, with a bit of luck, it will contain 108 rows. There it is. And as I scroll down, you can see the first 103 are the ones which were imported OK, and right at the bottom there's 5 rows where we couldn't import it because we couldn't find the corresponding mentor in the mentors table. So everything seems to work perfectly. As the final part of this tutorial, what we're going to have a look at is caching, ways to speed up the way in which your lookup transform works. We've got our package working perfectly, but the question remains, how quickly will it run? As it happens, I think the answer to that is very quickly indeed. We've only got 108 finalists, and we're only looking up 9 mentors, so I don't think speed is going to be an issue. But what would happen if there were 108,000 finalists, or perish the thought 108 million? In that case, we might be more concerned about how our caching is going to work of data. You can see the options by double-clicking on the Lookup Transform task and seeing the cache mode. And there are 3 possibilities: full cache, partial cache, or no cache at all. In full cache mode, what integration services will do is load up the entire lookup table of mentors at the very beginning of the task. And because there's only 9 of them, it won't occupy a great deal of memory. At the other end of the extreme is no cache. What will happen then is every single time integration services comes to a mentor, it will look for it in the table afresh and have no memory of what the table used to look up the last time it loaded it. This is clearly wildly inefficient. A sensible middle way, perhaps, is partial caching. What partial caching will do is set aside an amount of memory. You can actually control how much of it that is by going to the Advanced tab and changing the amount according to whether you're using a 32-bit or a 64-bit processor. We're going to use the default of 25 megabyte. In a partial cache, what will happen is this. Integration services will find Louis Walsh. It will look up Louis Walsh in the list of mentors and find that Louis Walsh is number 5. It will then create in its cache a miniature table containing mentor ID 5, mentor name Louis Walsh. When it comes to the next finalist, who coincidentally is also mentored by Louis Walsh, it won't have to go back to the lookup table. It will go to the cache and look it up far quicker from that. It will then add Simon Cowell to its cache, Sharon Osbourne, and so on. This technique clearly works best when you have a very large number of records, but only a few things that you're actually looking up, so the cache size remains relatively small. And partial caching seems the most sensible option to me. Now, in addition to that, you can also create something called cache connection managers, and that's what we're going to have a look at in the final part of this tutorial. The final part of this tutorial will consider a way to make lookup transforms work even quicker than using partial caching. It relies on the fact that getting information directly from SQL Server is actually not the fastest thing we can do. The quickest thing we could do would be to load our table of mentors, and there it is, into a special cache file with an extension of CAW. And to do that, what we're going to do is a cache transform. What we can then do is in integration services, rather than getting our information for the lookup directly from OLADB from SQL Server, we can get it from the cache file we've created. And this has two advantages. One is it will run much more quickly, because it's quicker getting information from the cache than it is from the OLADB. And the second advantage is that it may well be the case that somewhere else in our package we want to do another lookup from the same table. And we'll already have the cache file created, so we won't have to reload it into memory. So to get this to work, the first thing I need to do is go back to my control flow and add another data flow task. And what this is going to do is to load the mentors into a cache. What I'll then do is just run that straight into the next control flow task. If I then double click on that to configure it, I need to add two things to it in the data flow. The first is a source which tells it where the information is coming from. So it's going to get the information from the mentors table, so I can use a connection manager already set up. And if I then double click on that, I can choose the table itself and then choose OK. And for the sake of elegance, I'll rename that and call it mentors table. So that's where my data is coming from. The place it's going to, as mentioned, is a cache file. And to do that, I can use a cache transform. You won't find that in the common transform section, it's in the other transforms. So what I'll do is create my cache transform, feed my data from the mentors table directly into it, and perhaps rename it to say create cache file. What I'll then need to do is to configure this cache file. If I double click on it, the first thing I need to do is create a connection manager. I could have done this separately, but I'll do it as part of configuring the cache transform. So what I need to do is click on the new button. I'll call my new connection manager mentors table. And if I then go to columns, you can see that it's automatically going to take the mentor ID and the mentor name. Now at this point, when you're configuring a cache connection manager, there's a very easy mistake to make. What you should do is index the mentor name, because that is the field which you're looking up against. So for example, when you have a finalist, it's the mentor's name, Louis Walsh, that you want to find and nothing else. If you make the mistake of indexing the mentor ID as well, it would lead to problems later on in this. If I then choose OK to confirm that, and then choose OK, if I then go to mappings, you can see that it's taken the mentor ID and the mentor name from the original OLADB source and mapping onto the mentor ID and mentor name in the cache, which is exactly what I want to happen. So I can choose OK. So that's my data flow task complete. So the first thing which will happen when I run this package is it will load the mentors from SQL Server into a cache file, which will be available for my lookup transform. What I now need to do is go to that lookup. What I now need to do is go to my lookup transform, configure it, and say that instead of using an OLADB connection manager, so instead of getting its information directly from a table in SQL Server, I'm going to use the cache connection manager created. It says my connection type has changed, so I need to go to the connection tab and I need to choose a connection manager, but integration services have thoughtfully already done that for me on my behalf. Everything else will work exactly the same way it did earlier, but I need to check for my columns that it is matching the mentor name in the original finalist worksheet to the mentor name in my cache, which it is doing, and that it's spitting out the mentor ID still. So if I choose OK, My belief is that the only thing I've just changed is where the mentor's information is coming from, so it should work exactly the same way as it did before, but quicker. Let's see if it does. So if I click on the play tool to run that, it's exported all the data. If I go to my finalists and have a look at those, you can see it's imported 108 finalists just as it did before. The only difference is, if I just come out of debugging, at the time the package was running, it had created a cache file containing the mentor's details, which I could reuse in another transform. And that's pretty much the whole story on Lookup Transforms. I hope you've enjoyed what has been a slightly longer tutorial than average. Please come back for more in the series. You can find much more information on .NET, SQL Server and Microsoft Office training at www.wiseowl.co.uk.